Alright guys, we started a new unit today talking about quadratics. So I want to give you a little intro here, talk about what is a quadratic and some little tips that you can use to help you graph them. So some examples of some quadratics would be y equals x squared plus 3. That's a quadratic. Y equals x squared plus 2x plus 7. Y equals 17x plus x squared minus 3. Y equals negative x squared. That's a quadratic. So all of these things are quadratics. And what you're really looking for here is you want to make sure that the biggest exponent in the problem is a 2. Alright, so that's what makes it a quadratic. Some things that are not quadratics. So when you're learning something new, sometimes I want to know what is and what is not. So like y equals x plus 3 is not a quadratic because there's no 2 in the problem. Y equals 2x to the third plus x squared plus 2x. That's not a quadratic. It does have a quadratic part to it. There's x squared here, but since the highest exponent is a 3, this would be a cubic. It's not quadratic. Y equals the square root of 2x squared plus 3. Again, your biggest exponent is a 2, but it's inside a square root, so that doesn't work either. And finally, y equals x squared plus x to the negative 1. Again, your biggest exponent here is a 2, but you got this negative 1 here. And what that does is it makes this whole thing not even a polynomial anymore. So, that doesn't work either. Okay. So, moving forward, we now know what a quadratic is and what it's not. So what can we do with a quadratic? Well, let's start out with the most basic one, y equals x squared. What this is it's a quadratic. Another word you might hear it called, if you're talking about the shape of the graph, is a parabola. Okay, it looks kind of like a U, something like this. So to graph it, well, one way to do this is just to plot points. So if you plug in 0 for x, well, 0 squared is 0, so y would equal 0. So we have a point at the origin at 0, 0. If you plug in 1 for x, well, 1 squared is 1. So the point 1, 1 is on the graph. If you plug in 2 for x, well, 2 squared is 4. So the point 2, 4 would be on the graph. Alright. Same idea if you plug in negatives. Negative 1 squared would be positive 1. And negative 2 squared would be positive 4. So it turns out by looking at the graph, again, this makes kind of a U shape. Looks something like this. Assuming that you can hit your dots when you're drawing it. Notice that if we were to take this graph and we were to fold it across the y-axis, it would fold on top of itself. This graph has y-axis symmetry. Okay. Another word for this line that you're folding it over, because you won't always be centered at the origin, is it's the axis of symmetry. Cool name, I think. Axis of symmetry. So the axis of symmetry is this line, this imaginary line that runs down the middle of your parabola. If you were to fold over it, it would fold on top of itself. And this point down here at the bottom, that's your vertex. For the graph of y equals x squared, the vertex is at 0, 0. Notice that the axis of symmetry would be the line x equals 0. So whatever your x value is in your vertex, that's also how you find the equation of your axis of symmetry. Okay? So really that's about all we can talk about for y equals x squared. But there are a couple cool things that we've seen here. We've seen the axis of symmetry and the vertex, and we know what the shape of the graph looks like. One other cool thing here is to notice that the number in front of the x squared, we'll refer to that as a in the future. In this case, a is greater than 0. It's positive. It's a 1. If it's positive, what that tells you is that your graph is going to open upward. If, for example, we'll look at some here in a second, where a is negative, that tells you that your graph, your U shape, is going to open downward. Okay? Alright, so let's look at one. Let's do something crazy. Y equals x squared minus 4. That's a fun one. So looking at the graph of y equals x squared minus 4, we can do a couple things. The first thing that I want to do is I want to find the axis of symmetry. Because it's useful. If you can find that, then you know the x value of your vertex, and you can go back and find your vertex. So there's a nice little equation here. X equals minus b over 2a. Minus b over 2a. So this is your axis of symmetry. In this case, x squared minus 4, I guess I was talking about what a and b are. A and b are the numbers in your equation. A is the number in front of the x squared term. B is the number in front of the x. And if we had c, well, c would be the number that doesn't have an x at all. The constant term. So in this case, notice we don't have a b value. So our b is 0. And our a in this case is 1. So 0 over anything is still going to be 0. So our axis of symmetry is the line x equals 0. Same as it was up here. Alright? But when you're going to find your vertex, what you're going to do is you're going to plug in 0 as your x value. 0 squared is 0, minus 4 would be negative 4. So our vertex is going to be at 0, negative 4. Okay? One thing that we can do with this graph in particular is notice that if you think back to factoring, this equation here, x squared minus 4, that can factor. It's the difference of two squares. It factors as x minus 2 and x plus 2. And factoring has a really useful application when we go to graph quadratics, because it helps you when you go to find your x-intercepts. Right? So notice that an x-intercept, if you recall from what you remember in Algebra 1, that's when y is equal to 0. You're finding where does the graph cross the x-axis. So an x-intercept is when y is equal to 0. So if I take my equation up here in factored form and I plug in 0 for y, I get this. 0 equals x minus 2, x plus 2. And there's this rule in mathematics called the zero product rule. Notice that 0 is in the name because it only works if you have something equal to 0. And that something has to be a product. Product meaning that you're multiplying something together. So here we are multiplying x minus 2 times x plus 2, and that product is equal to 0. So we can apply the zero product rule. And what that does is it lets you split this equation apart. The x minus 2 part is set equal to 0, and the x plus 2 part is set equal to 0. And then from there, we can take each one of these and solve it for x pretty easily. You would just add 2 to both sides here, and on this part you would subtract 2. So what this tells us, the factoring here, helps you to find your x-intercepts. We have 2 of them, one at 2, 0, and one at negative 2, 0. So what I've done here is I've come up with 3 different points that are on my graph. I have one at 2, 0, one at negative 2, 0, and one at 0, negative 4. So given that information there, I can sketch in my parabola and see that it would look something like this. Okay. Notice from the other thing we talked about up here with the a value, in this equation, a was positive, so our graph should open up. And based on what we found, there's no other way to connect the dots such that it would open up and still make a U shape. So We know that we've done a pretty good job here. Just for fun, if you recall the quadratic formula, x equals minus b plus or minus the square root b squared minus 4ac all over 2a. This thing here is also used to find the x-intercepts. So if, for example, we had an equation that didn't factor, that we couldn't split it up and do the zero product rule, we could still use the quadratic formula here and find it that way. So let's go ahead and show the quadratic formula for this example, just so I can prove to you that this method here of the factoring works. So in this case, we didn't have a b, so that part's 0. We did have an a, though. It was 1. And we had a c. It was -4 all over 2 times 1. So in this case, we're going to get plus or minus the square root. Well, -4 times 1 is -4 times -4, which would be 16, all over 2 times 1, which is just 2. Here, the square root of 16 is 4. So I get plus or minus 4 over 2. Well, positive 4 over 2 would be 2, and -4 over 2 would be -2. So notice that you get the same numbers here that you got by factoring, and it's a whole lot less work. So if it factors, it's great. If not, well, sucks to suck, I guess. So one cool thing to look at here, the plus or minus square root part here. This is what determines how many x-intercepts you have. So when you're graphing a quadratic, it can do a couple things. So one thing that we can do here is, well, maybe my quadratic does something like this. It never touches the x-axis at all. In other words, this one has no x-intercepts. Okay? Or maybe it touches that and touches it just once. So here we'd have one x-intercept. Or maybe it looks something like this, and it crosses the x-axis twice. This would have two x-intercepts. Well, each one of these scenarios we can find and prove algebraically that this is the case by looking at something called the discriminant, the discriminant. Okay, the discriminant is the part under the square root in the quadratic formula, the b squared minus 4ac. Alright, so the situation where you have no x-intercepts, the reason for that is because b squared minus 4ac comes out as something that's less than 0. In other words, it's negative. Okay, so if b squared minus 4ac is negative, what's going to happen is you're going to get the square root of a negative number when you go to put it in the quadratic formula, and that never happens. You can't take the square root of a negative number, not at least when you're graphing in the Cartesian plane, in the normal x and y grid. So we can't graph complex things here. So b squared minus 4ac, if that's negative, that screws up your whole thing, and you're going to get 0 solutions to the quadratic formula. Okay, so you would have no x-intercepts in that situation. It would look like this. So if b squared minus 4ac is equal to 0, though, well, we can take the square root of 0. The square root of 0 would just be 0. So we'd have negative b plus or minus 0 all over 2a. Well, adding 0 and subtracting 0, that's the exact same thing. So you would just have negative b over 2a. That's your only solution. So you'd only have one x-intercept in that situation. Just one. And look like this, where you touch the x-axis once with the vertex, and then your graph will either go up or down. And then the final situation is where b squared minus 4ac is greater than 0. In other words, it's a positive number. Okay? So notice here, looking at the equation, if the square root of b squared minus 4ac, b squared minus 4ac is a positive number, well, then it's going to have a square root. It may not be a nice and pretty one, but it will have one. So you'll have plus the square root and minus the square root. And that's where you get your two solutions from. Another thing to notice by looking at this is that you have the minus b over 2a. That part right there, that should look familiar. That's because that's how you find your axis of symmetry. So what you're doing really with the quadratic formula, here, for example, there's your axis of symmetry. That's the minus b over 2a part. Now let's look at one that actually crosses. Something like this. So there's your minus b over 2a. And what happens is to find the distance to the x-axis, you're actually going over, in this case, the positive square root of b squared minus 4ac. So that's what this distance is here. Or if you're going the other direction, well, that would be the negative square root of b squared minus 4ac. So that distance right here is how far it is from negative b over 2a, where your vertex is, or your axis of symmetry. Over on the x-axis is this distance, which is cool to know. It's cool to know that's where the quadratic formula comes from. So I'm approaching the 16.5 minute mark. I guess I should probably stop here, and if I'm going to make more, I'll make a second video, I guess. So we've talked about some cool stuff here. We learned about what is a quadratic by looking at the powers, the degree, versus what is not a quadratic. We learned about this shape. It's U-shaped. We looked at the most basic graph. So that had a point at 0, 0, at 1, 1, at 2, 4, etc., etc. We talked about when a is positive, when the number in front is positive, your graph opens upward. If a is negative, your graph is going to open downward, which is a possibility. We looked at the axis of symmetry and the vertex and learned how to find those. We talked about factoring to find the x-intercepts using the zero product rule versus using the quadratic formula. This one will always work no matter what quadratic you're looking at, whereas factoring method only works if it factors. If it doesn't factor, you have to use the quadratic formula to find the x-intercepts. And then just as a little tip, you can use the discriminant b squared minus 4ac to determine beforehand how many x-intercepts your graph has. If you look at the discriminant and you can see that it doesn't have any x-intercepts, then you don't really need to waste your time with factoring, because it's probably not going to factor nice and pretty if you don't have any x-intercepts. So that's good information to know. Alright, so if you have any questions, feel free to leave a comment below. Otherwise, good luck in your adventures.